So the next topic of presentation is force amplification compliant mechanism for closed loop sensing. So from the previous discussion, we come to a point that like closed loop is providing the better advantage over the open loop. So we try to implement that closed loop mechanism into the another structure where we are integrating the conventional MEMS accelerometer with the compliant mechanism. Like Professor Anand Suresh sir is a very renowned for those structures. So we integrated both them so that we can see is there any better advantage of using them. So these are the basic understanding of the complaint mechanism where like day to day, I can say like fulcrum based kind of complaint mechanisms. So we took the advantage of that one, like where one side we can apply the input load, another you can see the exaggerated output load. So in terms of the amplification factor. So these were the some of the configurations are already pre-published and they are thoroughly from the Professor Anand Suresh group from IISc Bangalore. And these are the some of the accelerometers which used which utilized the complaint based complaint based configurations to sense the external excitation that was given to the MEMS accelerometer. So on the right side, you can see some of the previous work we published in the microsystem technologies based on these complaint mechanisms only. And this is the, like I'm excluding the remaining parts which I discussed earlier. Like this is the design which we come up with where we have a certain proof mass and the control. Like we have a interdigitated cone kind of structures for the controlling as well as the sensing purpose. And there you can see in the pink color, this is the compliant mechanism that we are talking about. It's a kind of a compound lever bridge kind of So we utilize the same concept of closed loop mechanism where the force can be applied. That's like restoring force can be applied through closed loop mechanism. That is the formula for the net force we are applying through terminals, which are, you can see the T1, T3, T4 and T4 and T3 are the controls. We are using it for our structure so that we will bring back the system from the displaced position to the equilibrium position. So this is the closed loop mechanism. Just a upgradation of the previous one which we have done. Like we felt like there needs to be certain parameters has to be updated according to this configuration. So we come up with this kind of closed loop mechanism. And then these were the certain results which we got for the ramp kind of input signal from -30 to +30G acceleration, where you can see that like better linearity in terms of the device utilization. You can see on the right extreme side, and the better control over the control voltages as compared to the previous case. In the previous cases, I need to supply the extra voltage to the systems to bring back to its equilibrium position because they are offering the parallel plate kind of what is I can say controlling force. But in this case, we are utilizing the parallel plate, but other configuration. Like there are two, tangential force and normal force. In this configuration, we utilize the normal force configuration to bring back the system to equilibrium position. In the previous case, I utilized the tangential kind of. That's why there you can see here the values are clearly in the differentiable range. So this is the advantage of using the closed loop mechanism with compliant based, where we can have the better control over the control voltages as compared to the conventional MEMS accelerometers. So this is the certain conclusions which we derived from this work. This is the better linearity. And one thing we observed, like in this, we did the study for with force amplification, without force amplification. Without force amplification, there is a better sensitivity, but we need to supply the more power to the system. That is not desirable. There has to be a trade-off between the voltage supply and the sensitivity. Then we come up with so we will take a trade-off by saying the sensitivity is minimal. The change in the sensitivity is very minimal. The reduction in the control voltage is very substantial. So that's the advantage we are getting from these devices. So these are the publications which we got out of this work. So interested reader can go through it, and that's it. And these are the references. And as I was telling earlier, so my guru. So happy to answer any of your questions.